Hello friends, welcome to VK Lectures. In this video, we are discussing the question number 49 from Karnataka Set 2024 Physics question paper. Consider the following canonical transformation. Which of the above transformation are canonical? For the transformation from small q small p to capital Q capital P is canonical only if the Poisson bracket QP of Q comma P is equal to 1. And for 1 degree of freedom, we can write the canonical transformation as capital QP canonical transformation of, or the transformation Q comma P, or this is the Poisson bracket Q comma P is equal to dou capital Q by dou small q into dou capital P by dou small p minus dou capital Q by dou small p into dou capital P by dou small q, and it should be equal to 1. Let us see which of the following options are canonical transformations. Let us take the first option, that is capital Q is given as half small q square p and capital P is given as small p by small q, and the canonical transformation equation is as given here. Q comma P is equal to dou q by dou small q, so dou capital Q by dou small q is equal to differentiate with respect to q for the first q, that is half q square p, so half p q square 2q, so pq. Now we need to find what is dou capital P by dou p, that is equal to capital P is p by q dou by dou p, so that's equal to 1 by q. Now we need dou q by dou p, that is equal to, with respect to p means half q square, so that will be equal to q square by 2, and dou capital P by dou p, so that is dou q dou small q, that's equal to that is with respect to p, so that is p minus p by q square. So the first two product minus the second two product, so that's equal to QP or PQ into 1 by Q, this is capital P comma Poisson bracket is equal to PQ into 1 by Q minus Q square by 2 into minus P by Q square, so that is equal to Q gets cancelled, so P minus of minus plus Q square get cancelled, P by 2, that's equal to 3P by 2. So this one is not canonical. So this transformation from Q, this small p small q to capital P capital Q is not a transformation, canonical transformation. Coming to the option number 2, the Poisson bracket of q comma p should be equal to 1. So we have the options to capital Q equal to small q tan p, and capital P is equal to small p minus 3 times cos square q. So dou capital Q by dou small q, so that's equal to tan p. Similarly, dou p by dou small p is equal to cos square q. Yes. So similarly, dou capital Q by dou p is equal to q tan q derivative is sec square p. Now dou capital P by dou small q is equal to derivative of this into this. So to the first term with respect to cos square, so 2 cos q sin q minus sin q. So 2 cos q into minus sin q into p minus 3 . Yes. So this is with respect to q. Yes. So the Poisson bracket p comma q or q comma p, what we can write, is the first two, tan p into cos square q minus q times sec square p into p minus 3 minus 2 cos q sin q, 2 cos q sin q. So this also, so this is also not equal to 1. So the second option is also not canonical. Coming to the option 3, capital Q is equal to root of q e to the power t into cos p, and capital P is equal to root of q e to the power t times sin p. Now dou q by dou small q, so root of q, root q derivative 1 by 2 root q, so 1 divided by 2 root q into this remains e to the power t cos p. Similarly, dou p by dou p is equal to root of q e to the power t sin p derivative cos p. Now dou capital Q by dou small p is equal to root of q e to the power t cos p derivative minus sin p. Again dou capital P by dou small q equal to root of e to the power t divided by 2 root q into cos p. Now this is equal to root of e to the power t. Oh, wait a minute. So let's see the transformation. Q comma p is equal to root of e to the power t divided by 2 root q into cos p times root of q e to the power t into cos p minus root of q e to the power t into minus sin p into root of e to the power t divided by 2 root q into cos p. This is sin p, made a mistake, sin p, sin p. Okay, so what is remaining is, let's write it as root q and root q get cancelled, so e to the power t divided by 2 into cos square p, minus and minus becomes plus, so that becomes e to the power t divided by 2, and root q, again root q get cancelled, so cos square p. So this becomes e to the power t by 2 into cos square p plus sin square p. This is again mistake. Sin square p. So cos square p plus sin square p. Cos square p plus sin square p is 1. That will be equal to e to the power t by 2. So this is also not equal to 1. So all the three transformations are not canonical. For the given transformation small p cap small q to capital P capital Q is canonical. It is already given that it is canonical. Find the value of t for which the given transformation is canonical.